Well, thank you very much again. Welcome back. Now I'll talk about a, a matching problem which appeared during the last few years, and it is essentially a generalization of the school choice model, although with a significantly richer scope. And because the problem originally emerged in the context of cadet-branch matching, I'll refer to the problem as cadet branching at U.S. Army programs or cadet-branch matching at U.S. Army programs. We have several subsequent papers which actually generalize what's going on there. Some of them are theoretical, others are about affirmative action. These are the original pieces which were written with more applied motivation. This presentation is based on two papers, and apparently I brought old slides. I mean, the slides are not much different except both papers are published now. The first piece already appeared in Econometrica, and the second piece actually appeared in Journal of Political Economy. So both papers are available. They are both published in 2013. Okay. So, and this is some marketing about matching markets. Last 10 years have been good for market design and matching markets. Theory pioneered by Galen Shapley matured to a point where matching theorists could make policy suggestions in key areas including education and healthcare. And some of the highlights are reforms of student assignment mechanisms in major school districts such as Boston and New York City, establishment of regional and national kidney exchange programs in the US and the UK, and recently, a few years ago, in a Congress testimony, Dr. Myron Goodman of NSF emphasized that research on matching markets has resulted in measurable gains for the US taxpayer. In research, people care a lot about the relevance of the results. I'm not entirely sure that that should be the only point in research. Certainly, I benefit a lot from theoretical research, but having those applications, policy relevance certainly helps quite a bit. And my take on the success of the field is the discovery of important practical applications backed by solid theory in the last 10-15 years. That's why I think last 10-15 years have seen lots of advancement in this field. So what I'll do in these two papers is I'll argue that this new set of problems might have some of the features which led to the success of matching markets. I'll introduce and analyze a brand new matching problem, which I'll refer as Cadet-Branch Matching at US Army programs. But you'll see that it actually is relevant for many other frameworks as well. More generally, I'll develop a model where part of the allocation is done based on priorities like school choice, and the rest is handled by the markets. And as economists, we understand markets very well. Then, with the research on either priority-based allocation or school choice, we also get a good sense of priority-based allocation. So one way to interpret the methods in this advocated in this paper is we are actually here developing a model where part of the allocation is done by markets and the rest is done on priorities. And I can think of many different frameworks where for some slots you use one criteria, for other slots you use other criteria. When I was much younger, there was this. My first job was at University of Michigan. I was hired as an assistant professor there, and there was this very competitive school. I don't remember remember if it was an elementary school, it might be, where there were two types of slots. One type, you had to get in the queue, literally. And for the others, I think it might be a lottery. And people would camp in front of that school for weeks for the first part. I mean, and there are many other applications where you use multiple criteria. People suggest improved mechanisms for United States Military Academy and ROTC. These papers also bring a new perspective to a recent debate on the scope of Hatfield and Milgram's matching with contracts model. Okay. So let me talk a little bit about the motivation for the applied part of the program, these papers. There are two main programs the U.S. Army relies to recruit officers. One of them is, the first one is United States Military Academy, also known as West Point. So that's the more widely known name, perhaps. And the second one is Reserve Officer Training Corps. West Point is a very elite academy, extremely competitive. I think they are number 4 in the number of Rhodes scholarships. I think to go to that academy, you need a letter of recommendation either from a congressman or a senator, if I'm not mistaken. It's an extremely competitive academy. Reserve Officer Training Corps has an entirely different structure. So in the U.S., at many colleges, you'll see these signs, join Army. When I was ill, I was wondering, how can you join Army? You're already at the college. Okay. Apparently, some colleges have ROTC programs with, it could be Army, it could be Navy. And if there's an arrangement like that, you can volunteer for the ROTC program, and you'll get additional training in the weekends, in the summers, and when you graduate from college, you'll also graduate from ROTC, and you'll be an officer of the United States Army. Okay. Once the school is over, so graduates of West Point and ROTC enter active duty for an initial period of obligatory service upon completion. Okay. So basically, you get this very elite education. You have to serve for the Army. That's the point, right? And the service, mandatory services, 5 years for West Point graduates, 4 years for ROTC scholarship graduates, and 3 years for ROTC non-scholarship graduates. Yeah, the exact years will be irrelevant for our story. And once you complete your obligation as an officer, you may apply for voluntary separation or continue on active duty. Now, the challenge for the Army is the Army ideally prefers everybody to continue. And of course, Army wants to maintain the ability to choose among those who are there. So the Army doesn't need to keep everybody, but rather be in a position to choose from a pool of elite officers. However, it turns out that for the last maybe 30-35 years, there's been very low retention rate of the junior officers, and as soon as the mandatory service time was over, higher than ideal rates of officers have left, which is not very good for many reasons, because Army, unlike the private sector, cannot just recruit people anytime they want. I mean, there is a big investment needed, and that wasn't very good. As a result, in the last 5, 6 years, the Army has responded to this challenge with some incentive programs, including a program known as Branch for Service Incentives programs. Okay, and today's discussion is exactly about this Branch for Service program, Branch for Service Incentives program. So to explain what this program is, I have to give a little bit more, some additional information about the jobs within the Army. So within the Army, if you are an officer, you don't have just the same job. Not all officers have the same job. There are specialties, right? These are called Army branches, and there are 16 branches. Some of them are extremely competitive and popular, like aviation, infantry. In general, a subset of these branches, known as combat arms branches, they are very popular, and you are more likely to advance in the profession if you have one of these, if you are a member of these branches. And the way you receive these branches is you compete for them in the fall semester of your senior year as a cadet. So as a military student is called a cadet. Okay? So in their last year, in the first semester, fall semester, they actually compete for these positions. Okay? And this selection, this decision is extremely important. For one thing, it determines your job in the Army. But also, career advancement possibilities are very different across different branches. The chances that you made a general differ across these, considerably differ. And you are in a much better position if your branch is a combat arms branch. Prior to 2006, the allocation process for branches was very straightforward. In the Army, whether you are at ROTC or West Point, they would rank all the students with a concrete formula, which is based on a weighted average of academic performance, physical fitness test scores, and military performance. Okay? This ranking is called Order of Merit list, and the score you have for that list is called Order of Merit score. So in the movies, when you see, I was the top of my class, so they are saying that I was the top of that Order of Merit list. And it's a system that developed over many years, and Army is a very hierarchical system, right? And it's very important to rank well in the system. Okay, so historically, ROTC as well as West Point was assigning branches to cadets using the serial dictatorship induced by Order of Merit list. And we just argued in the previous lectures that when there is only one ranking, the allocation process is extremely straightforward. And indeed, basically the method they used before 2006 is the only one that makes sense in an environment where there is a meaningful ranking. And in this environment, indeed, there's a meaningful ranking. Things changed in 2006. By the way, the following might not be clear. For ROTC and West Point, the only thing that relates them is both institutions produce officers for the Army, but their processes are independent. Order of Merit list is independent. So for us, there are two separate problems. Okay? And I'll talk about both of them. In 2006, because of the retention issue that I mentioned, Army started experimenting with ideas, and in particular, how can we keep officers longer in the Army? And you gotta give them something that they value, right? They tried cash incentives or incentives of that sort. It didn't work very well. And then they had this idea, I think very good idea, where they wanted to do the following. Most cadets really value their branch, which makes sense, right? It's your job. Okay? It has implications on, advancement prospects. And the idea was, why not for cadets who volunteer a longer commitment term, give some priority in the allocation process for the branches. Not for all slots, but for a fraction of the slots. So basically, they decided that, and the numbers are different for West Point and ROTC. For the case of West Point, they adopted a system where for 25% of the slots at each branch, the priority will be given to cadets who are willing to serve, not willing to serve, willing to commit for an additional 3 years. You might not commit, but you might still serve the entire term. Okay? So this was for commitment. For the ROTC, they did the same through a different mechanism, though, for half of the slots. So here the idea is basically cadets who are willing to commit longer will get some advantage in the assignment process to branches. Not for all slots, but for some of the slots. And I'll be very clear about the details. So let me formulate the problem. And the problem will have a few different versions depending on whether we are talking about the West Point application or our ROTC program, but the general structure is the same. A cadet branch matching problem consists of a finite set of cadets, a finite set of branches, a vector of branch capacities, a set of terms or prices. I apologize for using the term again with also T, and it's entirely different object now. So it just reflects my lack of imagination. This paper is written more than 15 years later, the previous paper. So here, terms are the length. It could be anything in principle. It could even be cash, actually. But for this application, the interpretation is the terms are things like how many years you commit. Like the base term is 5 years. Alternative term could be 8 years. Okay. So basically, the term here is literally the price in terms of commitment time. Okay. Cadets have preferences now, not only on branches, but branch price pairs. So I will rank, okay, aviation with 5 years of commitment is my first choice. Aviation with 8-year commitment is my second choice. Infantry with 5 years is my third choice. So that is the nature of the preferences. Depending on the application, it may or may not be possible to be unmatched. In particular, for the West Point application, being unmatched will not be possible. In that case, you will not have preference, so that this set will not include empty set. But for ROTC, actually, it is possible to be unmatched, and I'll talk about that, how that happens. For that application, we'll also need an additional empty set here. And there is a list of base priority rankings. Now, instead of talking about priority rankings, I'm now talking about base priority rankings. So this is actually uniform for all branches and order of merit list, although for my problem it doesn't need to be. So if you want to have a richer system where you give different base priority at different branches and some branches actually lobby for that, like for instance military intelligence wants a very different priority ranking than some of the other branches, okay? You can do that. Not with their mechanism, but with the correct mechanism you can do that. So in the model I will allow for that. But once again, this is the base priority ranking, and the policy might change some aspects of that priority ranking. So this is the priority ranking in the absence of these, the modifications, if you wish. Pi B is the base priority ranking, and I will use the following notation. When I say pi bi is less than pi bj, it's like first priority versus third priority. Okay, lower numbers meant to be better. I mean, to be honest, if I was writing the paper now, I would just use a relation, priority relation, rather than using cardinal representation. Then again, that's how I did it in the paper. So sorry for the bad notation. So here, pi bi less than pi bj means that cadet I has higher claims to a slot at branch B than cadet J, other things being equal. Ceteris paribus. We assume that cadet preferences over branch price pairs are strict. We also assume that cadet preferences over branches are independent of the price, which means each cadet has well-defined preference over branches. So what does that mean? So this second bullet is important. So what this is saying is, if I prefer infantry to aviation at 5 years of commitment, I also do so at 8 years of commitment. Now, under this assumption, the preferences over branch price pairs will also induce it will also induce a preference ranking over branches alone. It would be meaningful to talk about, this is the first top branch, this is the second branch. Whereas, if there were reversals, I wouldn't be able to do that. One very important comment here. This assumption, second bullet, helps me to describe Army's own mechanisms and kind of also helps with interpreting their mechanisms, but they are not necessary for the correct mechanisms. So even though I have this assumption here, I do not need it for the corrected mechanism, although certainly it can satisfy these properties. And indeed, many people mention that it's very possible that for longer terms you can prefer one branch, for shorter terms you might prefer another branch. Okay, that's no issue as far as the corrected mechanism is concerned. So here, this is the notation for cadet preference over branches alone. So that's the induced preference. Calligraphic P is the set of all preference over branches and prices, branch price combinations, and Q is the set of all preference over branches only. The outcome of this problem is what is known as a contract in this literature. So this terminology started with Hatfield and Milgram's matching with contracts models, and this paper is an application of matching with contracts model. Although, as we'll see, a key assumption that is used in their paper, the substitute condition, is not satisfied in this framework, even though everything works as well. And this is one of the contributions of this paper, showing that the substitute condition is not necessary for many of the desirable properties in this literature. Here, in this application, a contract is a triple which specifies a cadet, a branch, and the terms of their match. That would be 5 years, 8 years, whatever. Okay? So here T indicates the commitment between them. In other applications, it could be the salary. It could be many different things. In this case, it just specifies the mandatory service commitment. X is the set of all contracts, and an allocation X prime is a set of contracts such that each cadet appears in at most one contract and no branch appears in more contracts than its capacity. And I'll use some notation here. The calligraphic X is the set of all allocations. If I suggest that under a set of contracts, so basically if I use this notation, it means that IBT is in X prime. That's what it means. The contract which matches agent cadet I to branch T at price T is a member of X prime. And if you don't see cadet I in any of the contracts of X prime, I'll use the notation X prime I is empty set. It's just terminology. So what I'll do is, I will generalize elimination of justified envy, which is also widely referred as fairness in school choice literature. It's the same thing. I'll generalize that condition for this framework. Excuse me. For a given problem, I'll say that an allocation X prime is fair if, suppose, I'm envious of Maury's full assignment, not branch, full assignment. Maury get aviation at 5 years. I would rather have aviation at 5 years than whatever I'm assigned. The only reason could be he has higher priority, base priority than me for aviation. If the procedure, well in this case, if the allocation is fair. It's a direct generalization of elimination of justified envy or fairness for school choice. So basically what this says is a higher priority cadet can never envy the assignment of a lower priority cadet under a fair allocation. So I will tell you, so it is exactly like elimination of justified envy. But this framework is richer, and the reason is the following. It is still possible for a higher priority cadet to envy the branch assigned to a lower priority cadet under a fair allocation. Maybe he received aviation at 8 years, and I have higher priority. And I envy, and I got infantry, say at 5 years. I say, wow, Maury got aviation. I prefer that to infantry, which is well defined under the assumption that I was making, right? But this is still fair in this context because Maury was able to get aviation by paying higher for him. Okay, so it's absolutely correct that the fairness requirement here is a direct generalization of the original fairness condition in school choice. Although here it allows for still being jealous about the branch portion of the assignment, which wasn't relevant for school choice. Thank you. A mechanism here, and I will not necessarily only talk about direct mechanisms. So let me remind you what a mechanism in general is. a mechanism is a strategy space for each agent, in this case cadet, along with an outcome function, a mapping, which chooses an outcome for each choice of strategies. This is the standard definition of a mechanism. A direct mechanism is a mechanism, a direct mechanism is a mechanism where the strategy space is just a set of preferences for each cadet. Okay? So if you ask cadets, what is your preferences? If that's the strategy space, then we are dealing with a direct mechanism. I'm introducing here a richer possibility, more general mechanisms, because actually Army's mechanism, technically speaking, will not be direct mechanisms, although they'll be close to, in some sense, they'll be close to direct mechanisms. Okay, so what are some of the properties that are desirable in this context? Fairness. A direct mechanism is fair if it always selects a fair allocation. A direct mechanism is strategy proof if there exists, if truth telling is always dominant strategy. This is very much like the monotonistic property that I talked about in the context of school choice. Given two lists of base priority rankings, pi 1 and pi 2, I will say that pi 1 is an unambiguous improvement for cadet I over pi 2 if the following happens. Between the two lists of priorities, nothing other than my relative ranking changes. So nothing changes as far as the relative ordering of other cadets are concerned. My relative ranking weekly increase in every ranking and strictly increase in at least one ranking. Okay? So this is a very modest, it's a very, if you wish, careful specification, right? I mean, I could have considered a version where I don't look at other people's ranking sources or stuff like that. Okay, so nothing changed except I'm located better in at least some, and certainly it didn't go down in any ranking. Clearly, this is an unambiguous improvement for cadet I. A direct mechanism respects improvements if a cadet never receives a strictly worse assignment as a result of an unambiguous improvement. Once again, this is a natural extension of respecting improvements in the student placement model. Now, I will later on argue that this property is perhaps more crucial for the problem of Army compared to student placement problem. And basically the reason is, if a mechanism fails this property, and in the Army you obtain these priorities with effort. Right? So if the mechanism fails this property, in principle it might hurt the incentives to invest in your priorities. So in a way it can hurt the investment in human capital accumulation. I will show you some evidence about that for the case of Army. Of course, if a mechanism is not strategy proof, it doesn't mean that people can find the manipulation, right? But I argued that for the Boston mechanism, indeed, probably they do. We'll see a similar phenomenon here. Not with incentives for preference revelation, but rather their priorities. Okay. So this property, I think, is important. More important than incentives, I think, in this context. And, that's personal opinion, of course. So let me give you the West Point mechanism. And then I'll talk about ROTC mechanism. And I will have very little time to talk about the correct mechanism. But I think the intuition will be very clear, and those who are interested can read and understand everything perfectly. Okay? So in a way, I'll not focus too much on the technicalities, but rather some of the insights and practice. Under the West Point mechanism, all cadets receive an assignment. Nobody receives stays unmatched. Therefore, the preferences are only over branches and prices. For their application, there are two relevant prices. There's base price, and there's increased price, which is base price plus 3 years of commitment. I will refer any contract with increased price T2 as a branch of choice contract. Technically speaking, any contract which has T2 in it is a contract. The reason I call this branch of choice contract is actually that's what also Army calls it. So if you Google West Point branch of choice contract, you'll be able to download this contract. So this terminology correct both from a practical point of view and also from a theoretical point of view. So in every mechanism, there's a strategy space and there's an outcome function. Let me describe both of them. What is strategy space? Each cadet is asked to choose a ranking of branches alone. So they just rank the branches, not branch price pairs, but branches. And they also choose a subset of the set of branches. So basically what you do is you give a ranking of the branches and you choose a subset of branches, and the way this is implemented is you actually sign a contract, this paper, for each one you are choosing. So if I choose aviation and infantry as the subset that I'm choosing, I hand the Army 2 contracts, one for each of the branches that I chose. Okay? But technically, you are choosing a ranking of branches alone, and if you wish, you are putting a tick to some of your choices. It could be tough choices, but it doesn't need to be. So therefore, for each cadet, the strategy space is the set of preferences over branches alone, Q, which I defined as Q, times 2 the power set of the set of branches. And that's it. That's the strategy space. But what I'll do is I'll actually interpret this strategy space before I give the outcome function. Once I give the outcome function, what the mechanism is doing will be clear. But I will actually interpret the strategy space here. First of all, the interpretation of the ranking of branches alone is kind of obvious. This is the ranking of the branches as far as I'm concerned. Okay? What is the second component? That's the interesting element, right? So basically, loosely speaking, and I'll be a lot more strict in 5 minutes, for each branch that I'm signing a contract, so for each element of the set that I chose, I am indicating a willingness to commit for 3 additional years for that specific branch that I'm choosing in exchange for increased priority in that branch. So basically I'm signaling that if I couldn't get into the regular door, so if I couldn't get the regular, cheaper slots with my ranking, I am willing to commit an additional 3 years for preferential treatment for those slots. That's the interpretation of the slots that you are choosing. I'll be very clear about this when I describe the outcome function. Now, for each branch B, the priority for the top 75% of the slots will be determined by the order of merit list. But for the last 25% of the slots, cadets who sign a branch of choice contract for branch B receives favorable treatment. Okay? Which means there are two criteria now. Not just one criteria for each branch, but rather two criteria. One criteria is just order of merit list, and it's relevant for the first 75% of the slots. The second criteria is the adjusted priority ranking, which I here denote by pi b plus. And it depends on the strategy choice of the cadets. Any cadet who actually signed that contract will have higher priority than any cadet who hasn't for that branch. But otherwise, the original priority ranking will be used. So basically, once you choose your strategies as cadets, this procedure gives you a well-defined adjusted priority for each branch. Okay? Now I'm ready to introduce the outcome function, which will be very familiar. For a given strategy profile, the West Point mechanism determines the final outcome with the following algorithm, which I'll call USMA algorithm. At step 1, each cadet I applies to its top choice under the stated ranking of the branches. Very much like deferred acceptance. Each branch B holds the top 75% of the, okay, so basically each branch B divides the tentative allocation process, holding process, into two parts. The first one is for the first 75% of the slots. The second one is for the remaining slots. For the first 75% of the slots, they just use the regular ranking, base ranking. For the last 25% of the slots, they use the adjusted ranking, meaning they favor the cadets who signed the contract. Any remaining cadets are rejected, and then you repeat that. In general, at step K, each cadet who is rejected in the previous step applies to the next choice under the stated ranking, and each branch reviews the new applicants together with the ones that are on hold. And for the first 75% of the slots, they use order of merit list or the base priority ranking, and for the last 25%, adjusted ranking. And when does it stop? When does the procedure stop? The algorithm terminates when no applicant is rejected. All tentative assignments are finalized at that point. This describes the matching, but doesn't describe the price. Okay? So what about the price? What happens with the price? For any branch B, any cadet who is assigned one of the top 75, I'm sorry, any cadet who is assigned one of the top 75% of the slots, the cheaper ones, is charged the base price. Any cadet who is assigned one of the last 25% of the slots is charged the increased price only if he has signed a contract for that branch, but the cheap price if he hasn't. So I can still get a slot from the last 25% from any branch without signing the contract, although that would mean that I actually lost some priority, but still get it anyways, which could easily happen for less demanded branches, of course. Okay? So now this mechanism is actually pretty good, right? And certainly, I think it's very impressive. And indeed, the Army, when they designed this mechanism, had economists, PhD economists in their team. That being said, this mechanism is not as good as one might initially think. Okay? And I will show you one serious issue with this mechanism. Under this mechanism, if you look at this process, the mechanism is looking at my top choice. Okay? And maybe I'm good enough for my top choice at the cheap price, maybe not. If I'm not good enough for my top choice at the cheap price, if I happen to sign a contract, it immediately considers me for the expensive version of my top choice, without paying any attention to the cheaper versions of my latter choices. So essentially, this mechanism assumes that for me, by far the most important that matters is the branch, and only then I care for the price I pay. Price comes secondary in this algorithm, which means when I'm choosing either my ranking or the choice of contracts to sign, I gotta be very careful. If I sign a contract for my first choice, I'll never be considered for my second, third, fourth choices at the cheap price, unless, of course, I'm unable to do my first choice even with the expensive price. Okay? And as a result, I might feel like signing a contract only for my, for instance, third choice in order to not to give up the possibility of being considered for the top three choices for the cheap price. Or I might reverse my preferences and choose the contract accordingly. So basically, because of this issue, here under this mechanism, essentially the army is trying to infer cadet preferences over branch price pairs rather than directly asking it. It's kind of guessing the preferences. And I would say making some rather strong assumptions there. As a result of this observation, truth-telling may not be an optimal strategy under this mechanism. Furthermore, a Nash equilibrium outcome of this mechanism can be unfair. It can be parity inferior to a fair allocation, and it may penalize cadets for unambiguous improvements. So as good as the mechanism appears, it has serious theoretical shortcomings. I will later show that all these shortcomings can be overcome with a very slight modification. I will barely make a change in the mechanism. And in particular, so the Army has the following policy. Top 75% of the slots with exam scores or base priority, last 25% is the one cadets are getting a priority. I will not change that structure at all. So I will interpret this as I'm not changing Army's admission policy with this mechanism, but only the mechanics. And the change that I will do is, I will change the strategy space. Rather than trying to guess cadet preferences over pairs, the mechanism will directly ask what the preferences are over the pairs. And we will use deferred acceptance mechanism, although it will not be called cumulative offer process. But in terms of the mechanics, it's exactly the same idea. The mechanism is doing the same thing anyways, except with guessed. Yes? I have a result later on which shows that the outcome of the true mechanism, which I'll refer as the true mechanism under true preferences, basically cadet deferred acceptance mechanism if you wish, with the true mechanism will be equal to the Nash equilibrium outcomes of the Army's mechanism where cadets have lexicographic preferences. I don't know if this is related to what you are asking. It kind of felt like, and I only gave a partially satisfactory answer because I don't think I remember all the details of the theorem. But I will. I have a proposition about a point which seems to be related. So this new mechanism, this competing mechanism, it's not a real mechanism actually, but this will be a competing mechanism, will require relating cadet-branch matching to matching with contracts model introduced by Hatfield-Milgram and further developed by Hatfield and Kojima. So Hatfield-Kojima paper, theoretical paper by Hatfield and Kojima, will be particularly important and relevant actually. Can you remind me when the end time was? When do I finish? $37. Okay. Thank you. Before I do that though, let me show you another mechanism. And I'll be honest and right away tell that I think this is this mechanism is not as good as the West Point mechanism. I think, if you wish, correcting some of the failures of the West Point mechanism, relying on their own insight, will be easy. It's just the correct mechanism will be just a minor edit of their mechanism. Here, there will be more serious issues. More serious intervention will be needed. Let me give a bit of detail about the process there. ROTC, unlike West Point, does not allocate all the slots with a centralized process. For one thing, not all ROTC cadets get an assignment to start with. They first determine a minimum score needed to get into active duty. So the lower tail will be cut to start with. Okay. The remaining part is called active duty out order of merit list in their terminology. And then of these cadets, not all of them will be assigned their branches with the regular process. Only about 80 to 90% will be assigned through the regular process. And the rest of the slots will be held and assigned manually by the Department of Army Branching Board with a method that only they know, or maybe manually. So basically, Army leaves some flexibility in the allocation of seats under this mechanism. Yeah. Only about 80 to 90% of the slots are allocated through the formal procedure, which means even cadets who will get an assignment, being unmatched is a possibility with the actual mechanism, and then it will be up to the Army what you get. So as a result, set of preferences are over branch price pairs and empty set. As in the case of West Point, there are two prices, the base price and increased price, which is also an additional 3 years in addition to the base term. And the strategy space is identical under this mechanism as well. Each cadet gives a ranking of the branches and chooses a subset of branches with these contracts they are signing. The mechanism, though, the outcome function is very different. the outcome function will not be the same. Now, for the cadets, there is a base ranking order of merit list, right? And let's just look at the relevant part which made it. Active duty order of merit list. So when I say order of merit list, this is actually active duty order of merit list with their jargon. In this ranking, some of the cadets are at the top, others are at the bottom, right? This process will treat those at the top half and those at the bottom half differently. The process will start with the first cadet and then go to the next cadet, so on and so forth. But right at the median cadet, the rules will change. Okay? So there will be this discontinuity right at the median cadet. And this discontinuity will be important, of course, for the performance of the mechanism. And but otherwise, the following will be done one cadet at a time following their priority ranking. Okay? So you start with the top cadet. The mechanism will evaluate the cadet for the following 6 possibilities. The first one that works will determine the outcome. If none of them works, the cadet will be unmatched. Okay? So the cadet will be assigned the top choice at the cheap price if less than half of the slots are already full. If this doesn't work, you'll be considered for your top choice at the expensive price if 2 conditions hold. The first condition is if you actually sign the contract. Unlike in the West Point mechanism, even if you don't sign a contract, you are still eligible for the potential more expensive slots. You just lose priority, but you are still eligible. Here, you are not even eligible. Okay? The second half is reserved to cadets who signed the contract. Okay? So if you signed it, and if you also are not ranked too high, meaning if less than 65% of the slots are full, then you get your first choice. If more than 65% are full, you don't get it. And then the same thing is repeated, the second choice and third choices. So let me again explain what's going on. Cadets are considered one at a time, starting with the highest ranking cadet. They will be evaluated for their first choice, second choice, and third choice. 2 shots for each. The first one is if less than half of the capacity is full at that branch, at that specific branch, you get it at the cheap price. If between 50 and 65% are full, and if you sign the contract, you get that expensive price. None of the cadets at about the median is reserved any one of the last 35 of the seats, last 35% of the seats at any branch at this phase. Last 35% of the slots at each branch is reserved for cadets in the second half. Okay. Now, at some point you reach the median cadet, the rule changes. And in particular, this constraint about 65% being full is removed now. So basically, if there's a slot there, and if you couldn't get the top 50% at the cheap price, you can get it at the expensive price, provided that you sign the contract. So the only difference is the constraint. So basically, bottom 35% of the seats are reserved to the second half of the cadets at each branch. And that constraint is removed once you pass the median cadet. Okay? This is a very simple idea, actually. but it has serious implications on the mechanism, right? In a way, this mechanism is easier to understand than deferred acceptance type of mechanisms. Now, let's make a few observations about this mechanism. This mechanism only uses top three choices, so truth-telling can clearly be suboptimal. But I would say that's the least of the issues with this mechanism. Truncation is not the only reason for the lack of incentive compatibility. Another reason is, for instance, expensive options always considered right after the cheap option for each branch, very much like the West Point mechanism. That's another issue. Okay, but there is more significant. There is a deeper, what I see as a problem with this mechanism, and it is the structure of the priorities. So for the ROTC, if you look at the overall branch priority structure, I'm not talking about the base priority, I'm talking about this implication of that policy. For the top 50% of the slots, the priority is based on cadet order of merit list. For the next 15%, first of all, these slots are reserved for cadets who sign the contract, meaning those who are willing to serve, commit for more. And among them, priority is based on order of merit list. That's also, in principle, fine. But for the last 35% of the slots, these slots are reserved for cadets who are at the bottom 50% of the order of merit list, who have signed the contract. Now, that structure, as you can imagine, might hurt the system quite a bit. Right? Why is it that you are having preferential treatment for a fraction of the seats if you are lower performance? And what might that do to your incentives to invest in your, human capital? This is happening because essentially the Army wants to balance the skill level at each branch in a way. Right? That's the intention. And their solution is a very direct approach. Later on, I'll make an indirect approach. So there's this affirmative action constraint for the last 35% of the slots, and cadets at the upper half of order of merit list are denied access to these slots, whether they are willing to pay the increased price or not. So as a result, we have a similar proposition to the one that we have seen before for the West Point. Truth-telling may not be an optimal strategy under the ROTC mechanism. Furthermore, an equilibrium outcome of the ROTC mechanism can be unfair, parity inferior to a fair allocation, and may penalize cadets for unambiguous improvements. So this is the exact same proposition that we have seen for West Point. However, as similar as this result seems to West Point's mechanism, to the case for West Point's mechanism, fixing the shortcomings of ROTC mechanism will be more challenging than fixing the West Point mechanism. In particular, in order to fix all the shortcomings, we will need to alter the priority structure, because the priority structure itself has a structure that is kind of damaging. Okay. Now, here, the main difficulty is the following. For a given branch, the range of order of merit list where higher ranking cadets lose prior to cadets in the lower half of order of merit list is referred as dead zone by the Army. So Army actually knows this particular feature of the mechanism. They know that higher ranking cadets kind of lose prior to lower ones. And the region that this happens, they have a terminology for it. They call it the dead zone. Okay? So let's see what the dead zone looks like. Now, so this is Army slide. So this data is directly from the Army, okay, for 2011. And So here, so if you look at the vertical axis, each bar represents a branch. The vertical axis is the order of merit list position of the cadet. Top cadets are here, 0%, 10%, so on and so forth. Okay? So if you look at, say, aviation, the turquoise part is the part where half of the slots are filled at the cheap price. For aviation in 2011, that happened at around 15% of the order of merit list. Actually, this is active duty order of merit list. So by 15% of the cadet distribution, cheap slots are already gone. By another 5%, by 20%, the next 15% of the slots are also gone. By this point, if you are at the top half, you are ineligible for the last 35% of the slots. You are in the dead zone. So dead zone is here. And see, it's a dead zone. It's kind of wide, so it's difficult to see. But actually they specify. I will do this black, not white. But so the dead zone is anywhere between 20 and 50% for aviation, between 30 and 50% for infantry. So basically, if you are around like 40–45%, you are in a rather compromised position because all these branches, combat arms branches, a big chunk of them, you are ineligible. Whether you are willing to pay the added cost or not. Just because your score is not high enough and not low enough. Okay? You are in the dead zone for many branches. Okay, now, I found this forum discussion between cadets, and one of the discussions, for instance, is the following. I know a couple of people who end up getting S, I think that's satisfactory, at LDAC, which is, I think, Advanced Camp, who got their first choice of branch because they were in the 51st percentile on the active duty order of merit list. Had they gotten an E, which is a better grade, I believe, they would have most likely been in the dead zone. Okay? And then people who respond to this post are saying, are you saying they should have tried to get E at LDAC, which would have put them at 46% active duty OML, and not gotten their choice of branch? I don't disagree with you all, but these kids in the dead zone are 20-year-old cadets being faced with a moral dilemma. Do your best and kiss your branch choice goodbye, or screw up and get your branch choice. I think this is a strange choice to put in front of a young cadet. I think cadets are well aware of what is going on. And my understanding is, so this LDAC is what they do in the summer, I think immediately before this process. And from some of the discussions that I've seen here, they might be trying to influence their location, like try to avoid the dead zone with their performance, less than perfect performance through this stage. That's what it looked like. I mean, I have some of these published in the appendix of the paper, actually. As I mentioned, fortunately, it's possible to fix the deficiency of the West Point mechanism and even the ROTC mechanism, which requires relating cadet-branch matching to a recent model which received lots of attention. And this is the matching with contracts model of Hatfield and Migrum, which subsumes and unites Gale and Shapley's college admissions model and Kelvin Crawford's labor market model, among others. Now, in the original model, each branch is actually a hospital in their framework, and they have preferences over sets of agent-term pairs. So it's this is a two-side matching model, not priority-based allocation model. But these hospital preferences induce a choice set for each set of contracts. And it is this choice set rather than the preferences that is relevant, both for their model as well as for our model, actually. Policies in these choice functions, choice sets, as do preferences. So in that sense, they are very closely related. So in the present framework, branches are not agents and they do not have preferences. However, branches have priorities over cadet price pairs, and these priorities also induce choice sets. Okay? So we can use the techniques developed in Hatfield-Milgram and subsequent work with Hatfield and Kojima, and we can apply it in this particular context. Now, in general, the choice set of branch B from a set of contracts X prime depends on the policy on who has higher claims for slots in branch B. And basically what we can do is we can use West Point's policy, like 75%, look at score, plus 25%, look at the contractual term, and those who have the higher contractual term are favored. Any such thing, or even ROTC priorities, if you really want to maintain that, you can also use that in this particular context. I'll use the following terminology. For a given set of contracts X prime, the choice CB of X prime will be the outcome of the choice set. And what properties this set satisfies, in particular, some of that very much relate to Professor Murato's work actually on substitutes, will very much depend on the possibility of using a deferred acceptance type algorithm, as well as the existence of stable allocations in this particular framework. I will not have too much time for the theory there, but that's how this relates to the theory. I'll skip how to represent, ROTC choice set, USMA choices. I think they are all trivial. Okay, and I'll just skip stability as well. Defining stability here is also rather obvious. An allocation X prime will be stable if it is individuational, meaning no cadet or branches impose an unacceptable contract, and then there is no cadet I, branch B, and a contract between them which is not chosen, such that the cadet prefers that unchosen contract to whatever he is assigned, possibly empty contract, and the contract itself is qualified to be selected for that branch when it's evaluated together with the contracts that are chosen. So there's this unchosen contract which is qualified to be chosen with the choice function, which is like the policy of the branch, and which is also preferred by the cadet. So this is very much like blocking between a hospital and an intern, but here blocking is done with the branch using its own policy, if you wish. Okay. Now, three properties of choice sets or equivalent to branch priorities will be critical in this context. The first one is irrelevance of rejected contracts. This condition was kind of overseen and implicit in the original work, and became more explicit in some of the recent work, starting with my work with my student Orhan Aygün. So this property says that a contract which is rejected, if you remove it from the set of available contracts, it shouldn't affect the outcome. Okay. And then West Point priorities and ROTC both satisfy this property. The second property is law of aggregate demand, and it says that you do not choose fewer contracts from larger sets, larger in terms of set inclusion. which is also kind of natural condition. And in particular, it's satisfied both by West Point priorities and ROTC priorities. The third condition is the most important condition, and there's a huge literature on many aspects of that condition. It has various names, substitutes, cross substitutes. I think there is a name which has Murata in it, and so this is the most important condition. And this condition says that contracts are substitutes or satisfy this property if any contract that is rejected from a smaller set of contracts is also rejected when the competition is more with more contracts in terms of inclusion. If you couldn't make it with small competition, you don't make it with larger competition. In a way, in many setups, it's a very natural condition. Now, substitutes condition along with IRC, independence of rejected contracts, imply the existence of stable allocation. Okay, this is due to this is a reinterpretation of Hatfield and Milgram. This IRC condition is implicitly assumed in Hatfield and Milgram. I mean, their result would read: substitutes condition implies that stable allocation exists. One actually has to have IRC as well. Okay. So substitutes condition, along with IRC, have been very handy in the analysis of matching with contracts, and fixed point techniques in lattice theory has very strong implications on these conditions. Hatfield and Milgram built their model around the structure, and substitutes condition is assumed in much of the subsequent literature as well. Now, it turns out that a recent paper by Ekenike, a paper in AER, questions the value added of the matching with contracts model in the following sense. Federico showed that the matching with contracts model can be embedded within Kelso-Crawford labor market model under the substitutes condition. The opposite is correct, obviously, right? I mean, Kelso-Crawford is a special case of matching with contracts, but under substitutes, it turns out that the converse is also correct, meaning that the two models are completely isomorphic. And even the algorithms are identical step by step, actually. Okay? And perhaps that's one reason why we didn't see too many applications of matching with contracts in addition to the ones that we were already able to model with the earlier models. Okay? Now, substitutes condition is key for this result to hold. And indeed, Ekenike emphasizes that a recent theory paper by Hatfield and Kojima, that's their JET paper, analyzes matching with contracts under weaker conditions, and his embedding does not work under their conditions. Therefore, now, Hatfield and Kojima paper is a very abstract paper. It doesn't have applications, but very insightful, and it comes with two types of substitutes conditions. Okay. Now, one of the conditions offered in Hatfield and Kojima is the following. So this is a weaker substitutes condition. We'll say that elements of X are unilateral substitutes rather than substitutes for branch B if the only part that is different than standard substitutes condition is the red part, okay? If whenever a contract is rejected from a smaller set, even though it is the only contract belonging to that specific cadet, then it is also rejected from the larger set. So basically what it is saying is, it is sometimes okay for a contract that's rejected from a smaller set to be accepted for the larger set. But not if the contract that is rejected from the smaller set was the only contract of that specific cadet. So this condition allows for competition between a cadet's own contracts. Okay? Now, it turns out that the lattice structure of the set of stable outcomes no longer persists under unilateral substitutes condition, but a number of important results survives. I will tell you which which of the properties survive, but let me first make a few observations about our framework. In our problem, neither the West Point priorities nor the ROTC priorities satisfied substitutes condition. Actually, they both failed substitutes condition, but they both satisfied the unilateral substitutes condition. So this is the application that was missing with the new framework. And the reason this happens is the following. Think about me in the context of cadet-branch matching and consider two of my contracts, my infantry contract at 5 years and my infantry contract at 8 years. Suppose there is nothing available and the system has to choose between the two. When there is no competition, I can get my cheap contract. There is no competition from other people. Therefore, my expensive contract is rejected. But now let's throw competition from More, okay, which has higher base priority ranking. Now he can get the cheap slot. I'm unqualified for it, but maybe I'll now get my expensive slot. Okay? So basically the choice between my expensive slot and the cheap slot, not slot, contract, very much depends. And in particular, there can be these reversals very natural occurring in this particular framework, right? Okay. So indeed, cadet-branch framework is very natural for this extended matching with contracts model. So this observation begs the following question. What exactly had Phil and Kojima have shown under the unilateral substitutes condition? Okay. Now, in order to define this, I have to extend the deferred acceptance algorithm to this framework. And I'll call this agent optimal stable mechanism. Okay? And effectively, there can be multiple ways to obtain the outcome. It's very much like, the mechanics is very much like deferred acceptance algorithm. But the version that's described here is similar to McVitie-Wilson version of the deferred acceptance, where people are making offers one at a time rather than all together. That happens to be immaterial in this particular framework when unilateral substitutes properties is satisfied. Okay, so here cumulative offer algorithm does the following: fix agents in any way. The outcome will be identical no matter how you order the agents. That's a result. Okay? Then look at the first cadet. Look at his top choice contract. Okay? Let's interpret as if that cadet is making an application to the branch in the contract with that contract. Now look at the choice function of the branch. So far there is nothing there, and if it is qualified, it is accepted, otherwise it's rejected. And then go to the next cadet, so on and so forth. At some point, I give a contract to a branch. Because of this, maybe I'll be in and somebody else will be out. Okay? Okay? And then you can put that cadet who is now rejected anywhere in the queue, actually. It doesn't matter. Okay? And then this process eventually will converge, and the outcome is the outcome of the cumulative offer process. This is really deferred acceptance algorithm in this richer framework. Even though it's not, the offers are not simultaneous, nothing would change if it was simultaneous. And Hatfield-Kojima result is, assuming that the priorities satisfy the unilateral substitution condition and the IRC condition, then the cumulative offer algorithm produces a stable allocation that's weakly preferred by any cadet to any stable allocation. And if in addition the priorities satisfy the law of aggregate demand, it is also strategy proof. Okay? So basically the properties that are relevant for us actually extend to this framework. Okay? Now, as it turns out, a Kenicke embedding does not work in our framework. So Cadet-Branch matching problem is an application of matching with contracts that is beyond the scope of Kelser-Crawford. But for this, we need to go beyond the substitute condition. Okay? Okay. Now, how do we fix West Point mechanism? West Point already has its own priorities. Keep it exactly as it is. But instead of guessing cadet preferences, ask them. Use a direct preference, the direct mechanism, and use the resulting cumulative offer process. Okay. If you do that, the outcome of this mechanism will be stable under Army's own priorities, and it's weakly preferred to any cadet to any stable allocation. Moreover, it's strategy proof, fair, and it respects improvements. Okay. So all the failures that we had are now corrected with a minimal change, which is very important in market design. You know, we make suggestions as for, you know, we suggest different mechanisms under the model that we have in mind. Maybe the model is accurate, maybe it's not. Okay? But the bigger the gap is with the actual practice, the more likely it is you are making a modeling mistake, which might deem what you are doing rather irrelevant. Okay? So in that sense, I would suggest that this change is too minimal to really upset anything about our Army's additional objectives, if there is any such thing. Now, this is the result that I mentioned. Fix a cadet branch problem and let SI be the strategy choice of cadet I under the Army's own mechanism, USMA mechanism. And now for each cadet I, let's construct the following proxy preference relation PI star. Okay, so I have like 5 minutes, right? Oh, I'm done? Finish. Okay, so basically what it says is, assuming that the preferences are so basically what this is saying is, if the preferences were indeed lexicographic, in the sense that you first consider the branch and only then the price at equilibrium, at Nash equilibrium, the set of equilibrium outcomes under Army's own mechanism is exactly equal to the outcome of the correct mechanism under the proxy preference relation, which is with the relation with the lexicographic preferences. Okay. Unfortunately, I was unable to talk about the ROTC's correction, which would actually relate some of this work to bidding, and in particular, what I would do there is we, instead of using this dead zone, we use multiple prices so that with the use of these prices, more motivated cadets, even though if they have lower score, can make it to the class, which might help with the affirmative action objective. But this will be a mechanism where now part of the mechanism works very much like an auction, and the other part is very much like price-based allocation. Okay? With that correction, all the properties are maintained. Okay? So I apologize for going short, but all the more reason to read those papers. And thank you very much for your